Another way that we can make amides is by reaction of acid chlorides with amine, but in this instance we have to use two equivalents of amines, and that's because of the acidity of the leaving group, which is going to be HCl. Alright, so let's take a look at how that reaction works, and again you'll see it will follow the same pattern as what we've been talking about. This is going to be a neutral process because we don't have any H pluses or negatives above the arrow, so we're going to follow the neutral pattern here when we're doing this process. As I said earlier, we're going to need two equivalents of amine, and that's because the amine is basic and the HCl we're forming is acidic. And I'll explain the consequences of not using two equivalents of amine in a second. Alright, so let's go ahead and show the mechanism. And what's going to happen is the nucleophile is going to come in, attack the C double bond O. Then the O negative comes down, kicks out the leaving group. Remember, this is not a very common process. It only happens because the Cl is such a good leaving group. We don't often get negatives and positives in the same compound. It's usually something we try to avoid. And then we can have the H plus leave. And that gives us our amine, but we're not quite done yet. Our amide, I should say. But we're not quite done yet. As you can see, we formed H plus and Cl minus, which will add together to give HCl. Now the HCl then will react with the other equivalent of amine, to give an amine hydrochloride salt. Now if you're interested in the mechanism for that, it's fairly trivial actually. The N takes the H plus, and we end up with NH3 plus, which will combine with the Cl minus, and it's going to be the counter ion. I'll leave that over here too. So this will just be an amine hydrochloride salt that gets formed. So as you can see, if we did not include this second equivalent of amine, here's what would happen. We would form the amide, at least with half of the amine, and then as we formed HCl, the HCl would react with the amine that had not yet reacted. So we would end up getting half of the yield that we would expect to get, because what would happen is the other half of the amine would have reacted with the HCl that we'd get from the reaction of the amine with the acid chloride. So what we're effectively doing is adding in an extra equivalent of amine to take care of the HCl that gets reacted, so it doesn't react with the amine that's actually reacting with our acid chloride. So it's going to be important in this instance to include that second equivalent. It's usually amines that we worry about with this particular process, and that's because they're so basic. Other things like alcohols aren't very basic, so we don't really have to worry so much about the addition of a second equivalent of nucleophiles so that we can get our 100% yield of our product. But both of these are going to be the organic products of this process. One amine to react with the acid chloride, the other amine to react with the HCl that gets formed during the process. Right, just showing you how to base the pattern here. We've got the Cl, which is going to be the Y group. We've got this over here, which is going to be the X group. I'll draw this out a little bit more clearly. There we go, there's our X group. And here is the X group here, replacing the Y. And the Y group is actually going to be the YH, is actually going to be HCl. But the HCl reacts with the second equivalent of the amine, and that's how we get the second product here.